This question begins by testing whether you know what a type 1 error is and what a type 2 error is. There's no context in part A, so we just need a general definition of what a type 1 error is. Now, a type 1 error is rejecting H0 when H0 is actually true. So we're not asking for the probability of type 1 error, just simply what is a type 1 error, and that's it there, rejecting the null when the null is really true. We don't know how we found out that the null is actually true later on, but we don't need to worry about that. Now, type 2 error is very closely linked to that, and this is not rejecting the null hypothesis when we should have. So not rejecting the null hypothesis when it turns out the null hypothesis was actually false. Remember, these are both errors. So if we're not rejecting the null and we know it's an error, then it turns out we should have rejected the null. So it was false in this case. Now, part B. Make sure you read the question. I'm not going to read that out. So pause the video now if you haven't already read the question. So part B begins with the probability of a type 1 error for this test. Let's call X the number of defects. I'm just going to get rid of this box. Let X be the number of defects. So the chance of a type 1 error, well, that's what the actual significance level is. We're working with Poisson distribution here. The null hypothesis is Poisson is 6. The alternative, lambda is less than 6, because the question says test to see whether it has decreased. So lambda is less than 6. The chance of a type 1 error is the actual significance level. This is a discrete distribution, so we can't get it perfectly to be 5%. And this question does specify we want to get as close as possible to 5%, as close as we possibly can. So it could be less than 5%, it could be more. So using the Poisson tables, or alternatively the list function on the Casio ClassWiz calculator, we can narrow it down to these two values. The chance X is less than or equal to 1. I've gone less than because of the alternative hypothesis. It's 1.74%. Less than or equal to 2, 6.20%. Which one is closer to 5%? Well, that's obviously the 6.2%. So part B, the chance of a type 1 error, 6.20%. In part C, given that the true mean is actually 4, again, we don't need to worry ourselves with how that was actually found out, but given that the true mean is actually 4, what's the chance of a type 2 error? Now, the chance of a type 2 error is the probability that we do not reject the null. And since we've just worked out that our critical region is going to be X less than or equal to 2, that's what we chose as our critical region, less than or equal to 2, then the values of X where we would not reject the null will be values outside that critical region. Remember, this is a one-tailed test. So anything bigger than 2, and we're not rejecting the null. So type 2 error, the chance we do not reject the null when it turns out the null was false. And in this particular case, lambda is actually 4. So we need to be given a true value to be able to work out a chance of a type 2 error. So using Poisson 4 on the calculator or the tables, work out the chance X is more than 2. So you're going to do 1 minus the probability X is less than or equal to 2. Either using Poisson CD on the calculator or the tables. Make sure your lambda is 4 here, not 6. And we get 76.2%.